if this is a rod, velocity of the rod is v naught. Then this distance is say like a d, length of the rod is L, which is having a mass m. The coefficient of friction between the rod and the horizontal surface varies like this here. I'm just giving some basic idea how mg will act into the plane. A rod is moving on a rough surface where the coefficient of friction varies along x-axis mu equal to mu naught x. What is this description? You can take some pencil, move on the rough surface. Rod AB is moving with velocity v naught along y-axis as shown at an instant on a rough horizontal surface. So that xy plane is horizontal surface. Not this one. Xy plane is horizontal surface. Now how mg will act into the plane. And now the rough horizontal surface where mu varies mu naught x here. Tell me like I want torque by the friction about origin. What you are going to do here? Again, the same method is same. You are going to choose a small element of length dx. Let it be at a distance x. Then how the friction should act here like this df. The friction acting on the rod at different points will be different at that instant only. The question is only at that instant. So again, they use same method. The magnitude of friction acting on the rod at several points, it will be different here. Okay, now see, it's an
So,
unlimited way
sir,
of. Yeah.
how is friction in that direction, sir? I mean, horizontal surface.
XY is horizontal surface. Okay, no. And G will act along negative Z axis. Able to understand the question? So sorry, this Z X minus Z plane. X minus Z is the horizontal surface. G is acting along negative Y axis. And the friction will act along positive Z axis. Oh, okay, the problem has become. Yeah, the friction will act along negative Z axis, positive Z axis. df, I'll show it in this way. Okay, agreed. This one. Or you can convert in any either of this one, or just you do one thing, take some pen or pencil, that one. Just try to move with the horizontal velocity v naught, and assume that mu varies along the length of the pin. Fine. So now the df here to take in this direction. So this will set up a torque about 0.0. He is going to ask what is the torque by the friction. I'm just sharing several ideas. Huh? Find the net torque by friction about 2. If you want, I'll include the question later on. So variable force also will set up a torque. So till now what happened, we discussed like the point of application of force is only at one point, but here the force will act at several points on a body and a torque will also be set up by that.